The steps that we have been talking about, take out a GCF. Remember, you can do that in Desmos. And when you do that, remember we need to write what the GCF is, right? So we don't forget about it. And then we've got our 2 parentheses for our answers. Set up our blocks, A and C. This is the part some of us are messing up on, your signs. If C is positive, the signs are the same as B. If C is, so if it's a positive B, positive, positive. If B is negative, negative, negative. If C is negative, the signs are different. Remember, we have to multiply A and C and make our T-chart list all those factors. Plug them in to our box. Remember, we're looking for what multiplies to give us that B. Then you can start taking out your GCF to get your answers. That will go up here with if we had a GCF to begin with, okay? So we'll go through the steps. Is there a GCF? No. Okay, we can even put a 1 right here if we wanted. There's not a GCF between 6 and 1 and 5 because if there's a 1, then the only thing they have in common is 1. So we're going to skip that first step and we're going to set up our box. Let's draw our box. Remember, A goes in this top left, so we're going to say 6. I'm going to use X instead of D. C is going to go down here, positive 5. Think about your signs. C is positive. How do we get a positive when we multiply? They have to be the same or they have to be different? They have to be the same, and it's going to match our sign of B. So this is a negative something X and a negative something X. And when we put them together, they need to equal negative 1. Okay? All right, so that was step 2. Step 3 says A times C. Okay, so what's my A? 6. What's my C? 5. 6 times 5 is 30. Okay? So we're going to list our factors of 30. I mean, we've been doing this for a couple of days now. Just go down the list. 1, 2, 3. 4 doesn't work. 5, 6. It made a U, so we're done. And now we're looking for, remember, C is positive, so we got to add. Can we add any of these numbers to get a negative 1? Is that possible? No, this is 31, this is 17, this is 13, this is 11. None of those equal negative 1. So what does that mean? That means that this cannot be factored. If we do all these steps and none of them match our B, this cannot be factored. We call that prime. So which answer choice would be best for us? D, definitely. There are no real factors. Okay? It's kind of a bummer when we do all of that work and then you're like, oh, we can't do anything. That's kind of frustrating. But I wanted you to see that, in fact, sometimes there's not 2 binomials that multiply to make that trinomial. Let's try another one here. Is there a GCF? That's where we always want to start. Is there a GCF? No. We're going to draw our box. We're going to set it up. A is 1x squared. C is 16. C is positive. Are the signs the same or different? They are the same, and they're going to match B. So we know this is a positive something X and a positive something X. A times C, right? A times C, so 1 times 16 is just 16. So list your numbers. 1 and 16, 2 and 8. What else? 4 and 4. All right, remember, these in the middle have to add to be b. My b is a positive 8x. Which of these, because c is positive, that tells us we're adding them. Which of these factors can we add to get 8? 4 and 4. Now we can take the GCF. Do you want to go across first? What's your GCF on this row? Do we have any number GCFs? We have 1 and 4. Those don't have anything in common. What about x squared and x? Remember, if we have x squared, we know it's going to be x times x, okay? And then, so now, something times x is 4x. What times x is 4x? 4. What kind of 4? Be careful with your signs. Positive. And then I have x times something is 4x. What? Positive 4. So my factors, my answers are x plus 4 times x plus 4. Which one looks like that? B. Not D. D has minuses, so be real careful with your signs. This one is a special case in the sense that we got the same number, okay? And the reason is because 16 is a perfect square, right? Can we take the square root of 16? What do we get? We get 4, okay? Sometimes if it ends in a perfect square, that's part of the special cases. It's going to be the same number. If you don't like that, then just stick with box, and that works every time. All right, there is not, well, is there a GCF? Could we check? No, there's not, because 49 is 7 and 7. 9 is, can we do 7 into 9? No. Okay, I do want you to realize what I was just talking about, that this is a perfect square and this is a perfect square. We're going to talk about where that comes into play. Okay, so we are going to do our box here. 9x squared and 49. Same or different signs? Look at C. Same or different? Same. And it's the sign of B. So positive something x and positive something x. So A times C on this one is pretty ugly. 49 times 9, 81, 36, and 8 is 441. Now, I don't know about you, but I really don't want to find the factors of 441. Okay? So, when the numbers are really big like this, that trick I was talking about with this being a perfect square, tell me about the square root of 9. 3. So if you have a perfect square, we can take the square root. Tell me about the square root of 49. 7, and we know it's a positive because these are positives. That is when the trick comes in handy, because those are some really, really big numbers. I don't know about you, I just do not want to list all of those factors. So if it's a really giant number, I would look to see if those are perfect squares. And we can even check that this works. 3x times 7 is 21x. 3x times 7 is 21x. What do I get when I put these together? 21 and 21 is 42x. Is that what we wanted? Yes. So what's my answer here? It's going to be D. 3x plus 7 quantity squared. Now, remember to check this. Definitely put it in Desmos. And even you could, since this is multiple choice, you could put all of these in Desmos and find the two that overlap. Okay? What do you notice about this one? I only have 2 numbers here. So what's my missing number? 1x squared. Okay, so what do we write if I have plus something x minus 100? How do I show that there's nothing there? What number do I put? I put 0, yeah. So you can still do your box here. You can set it up. 1x squared minus 100. We know this is x and x because it's x squared. And I know that this needs to equal 0. So look at your C. It's a minus. What does that tell us about our signs? Same or different? Different. A positive times a negative is a negative. So I have negative something x and positive something x. And if I want that to be a 0, what do I know about those two numbers? They got to cancel out. Yeah. A times C is 1 times 100. Tell me about what makes 100. 1 and 100. 2 and 3 doesn't go. 4 and 5 and 26 doesn't go. 7 doesn't go. 8 doesn't go. 9 doesn't go. 10 and... Ooh, if they need to cancel out, which one is our numbers? 10 and 10. So then I have x minus 10 and x plus 10. So what's our answer going to be? Which one of these is one of the numbers we wrote? C. Okay, so this one, when you only have 2, we can do that little trick also. What's the square root of 100? 10. Okay, so if you want it to be a 0, okay, if you only have 2, you can do this trick. Those numbers aren't super ginormous, so you probably could have figured it out. Do pay attention, though, to the sign. One is positive and one is negative. So we would normally write, if you needed both of the factors, x minus 10 and x plus 10. There is no GCF on this, and we are missing a number. So if we wanted, what do we put when we're missing a number?
0.
We're putting a 0. So we need things to cancel out. Here is our box. Set it up. 9x squared. Minus, if it's a minus 16 from my C, are my signs the same or different? They are different, and we want them to cancel. Something minus x and a positive x. These need to become a 0. So 9, you got to do A times C. 9 times 16 is 144. Is that right? What do you know about 144 that's going to cancel? What makes 144? That one, so it's the same number when we add and subtract. Is 12. Is 144 a perfect square? Yes. Minus 12 plus 12. And now you can take out your GCF. What's a GCF in this first row? What's a GCF with 9 and 12? 3. So 3 times 3 is 9. Ooh, that's a perfect square too, isn't it? And then we're left with, what kind of 4 right here? Negative. What kind of 4 down here? Positive. Did you notice that 16 is a perfect square also? The square root of 9 is 3. The square root of 16 is 4. So our answer is going to be C.